We've learned a lot of different techniques for factoring polynomials up to this point. In this goal topic, the job is not to learn a new technique, but to prioritize the techniques we already know in order to be able to factor an expression that may require more than one of those techniques to factor completely. Here, the expression we begin with is 9x to the fifth plus 24x to the fourth plus 12x to the third. While it is a trinomial, having three terms, it is not a quadratic trinomial. Its highest power is not 2. Its powers are 5, 4, and 3. So chances are we're going to need more than one technique in order to factor this particular expression. The best technique to use first, strategically, is to look for a monomial greatest common factor. Do the three terms have a greatest common factor in common that can be factored out? In this example, looking at the terms 9x to the fifth, 24x to the fourth, and 12x to the third, shows that there is a greatest common factor, namely 3x to the power 3. We can factor out 3x to the third and be left with the leftovers 3x squared plus 8x plus 4. And that makes our job considerably simpler, because now the trinomial that we see, 3x squared plus 8x plus 4, is in fact a quadratic trinomial, which is something that we have other techniques to be able to factor. So that's what we'll look at next. What technique will allow us to factor this quadratic trinomial? Either the sum and product or the AC method will be appropriate. Because our leading coefficient here is 3 and not 1, the AC method is going to be the way we should try. In the AC method, remember, we're going to look for a pair of numbers which multiply together to give us A times C, which is here 3 times 4, or 12, and that same pair of numbers has to add together to give us the middle coefficient, 8. So what pair of numbers have a product of 12 and a sum of 8? That would be 2 and 6. Remember, in the AC method, those numbers get used to split the middle term, 8x, into 2x plus 6x, and then the result is group factored, factoring the first pair of terms and the second pair of terms separately. The first pair of terms here has the greatest common factor of x, the second pair of terms has a greatest common factor of 2, and when those GCFs are factored out, we end up with x times the quantity 3x plus 2 times the quantity 3x plus 2. Because that 3x plus 2 factor is common to both of our terms in our factored expression, we can factor it out, and what's left over is x plus 2 on the outside. So we've successively used the AC method to factor this trinomial as x plus 2 times 3x plus 2. Don't forget that our greatest common factor we factored out at step 1 has to be a part of our final answer as well. So we'll bring the 3x to the third down to give us a complete factorization of 3x to the third times the quantity x plus 2 times the quantity 3x plus 2. If there were an opportunity to do so, we would also look now to use the difference of squares factorization technique. But here we have no opportunity because we have no perfect square minus perfect square factors that are left for us. So at this point, we can say that we're done. Probably the most important aspect of the way that we prioritize the factorization methods that we've learned is that the greatest common factor method is probably the one to always think about using first. Before you worry about anything more sophisticated, ask, do all of the terms in my expression have something in common that may be factored out? In this example, we were able to factor out a 3x to the third power from all three of our original terms, and the expression that was left over was then a quadratic trinomial that we knew how to factor using another method. In this example, that was the AC method. In a different example, it might be the sum and product method, or it might be a difference of squares method. But the important thing is to factor out that greatest common factor first, and then after that, look for other methods to factor the quadratic expression that's left over.